Hi, I'm Paul Jermain. Welcome to another session of Smart Boating. As you know, if you watched the show before, we cover a variety of topics from man overboard to marine insurance. And the general idea is to give you a bit of information that'll help you make smarter decisions and have more fun on the water. Today we're in Dover, New Hampshire, our R&L Engines, an engine rebuilding shop, with the president, Leo Crossetier.
Good morning, Paul.
Leo, good to see you.
Welcome, and thanks for having us aboard.
Thank you. Hey, we've got a cool show here coming up today, which I think people are going to learn a lot about the intricacies of engine rebuilding. But before we get into it, can you share a little bit about when you got involved in the area and a little bit about the shop?
I sure can. This has been a lifelong passion for me as a young child, and I wanted to be an engine builder. Mm-hmm. And now, having pursued it 40 years later, we've got it to a level that is pretty exciting.
Yeah.
I do it with my wife, who's been with me with most of the 40 years, and we have a total staff of 7.
Okay. All right. So you've been doing it quite a while, so you got a lot of experience and just the right experience, so why don't we get right into the show? Exactly.
Look forward to it.
All right. Well, Leo, this whole activity of rebuilding engines is a pretty complicated one. Got a lot of pieces in the process. We can spend days on it, but we don't have days. We have a half hour. So I think within that half hour, we can focus on the most important points to highlight for people in this process. And of course, it would start with the receiving part of the operation. Here we are in the receiving part of your shop. Can you explain what we got here and what's going on?
Yes, Paul. Keeping in mind that we're a custom engine builder, we do a variety of engines. Mm-hmm. So it may be a classic, an antique, it may be a high performance or a drag race type engine.
Okay.
A broad scope of engines. Mm-hmm. What we have with us here today is a flathead Ford. This engine was manufactured back in the mid-late 30s.
Wow.
And we've broken it down yesterday, so basically these parts now are getting ready to go through the inspection and cleaning process.
Yes.
And what you see in front of you are 3 basic areas.
Okay.
The cylinder block, which is what contains all of the rotating and reciprocating components. Mm-hmm. You've got the crankshaft, which converts our reciprocating motion to a rotating motion. Mm-hmm. And that, of course, is connected to all of the piston rod assemblies. These are your 8 cylinders, if you will.
Okay, so that goes in here.
That goes in here.
Yeah.
And then what we've got to do is to take all of these pieces, do an inspection at this point, as they then go through the cleaning process. Mm-hmm. So we've broken this down, and it's now ready to start its motion through that process.
Well, Leo, once things pass out of receiving, maybe there's an initial breakdown, they go into an inspection process. And can you explain the process and the tools that you use as part of that?
Yes, Paul. What we have here is a cylinder head that is off of 1972 Jaguar. Mm-hmm. We do a lot of British work, and in this case the head has been broken down, and we're just starting to do the inspection part of it. Mm-hmm. So the first thing we're going to do is we're going to take all of the valves. We're going to see if they're in a serviceable condition. So with a micrometer, mm-hmm. we're going to measure them in several areas, and we're going to see if they have an allowable taper. We'll also check them for visual wear, the lock grooves, the tip, mm-hmm. the face, mm-hmm. and then we're going to run that in conjunction with our checklist. Okay. So whether it's myself or any one of my staff, mm-hmm. we have a checklist that we're going to go through. Okay. For everything. This is just for cylinder heads.
That gives you that consistency in terms of the inspection process.
It's a recipe just like baking bread. Yeah. Mm-hmm. So we want to go through the check process, and then we can develop our work order. Yes. We'll also develop a bill of materials. So we're going to know what we need to do for parts.
I noticed you got another form here too. Are those the specifications of what those parts should look like?
Yeah, so from our database, we've taken and we've printed out all the specifications for the cylinder head, mm-hmm. the cylinder block, the crankshaft, the connecting rods. Everything is here, so I don't have to run around. I've got everything at my fingertips to go through this inspection. Right.
So a very important part of the process.
We want to have all the information in front of us, keeping in mind that over the last 100 years or so, there are virtually thousands of engines. Mm-hmm. And so there's no way that any one of us can remember, oh, this should be X number of size. Right. We've got to go back and check it, see what the tolerance is, and then make our determinations. Okay.
Well, Leo, after the preliminary inspection of the parts, you have to clean them thoroughly, and this oven, if you will, is part of that process, right?
Yes, Paul. In this case, what we have in front of us is a cylinder block. It's gray cast iron. It's from a 1950 Ford. It's what's called a flathead Ford. This particular engine block is roughly 70 years old.
Okay.
It's never been apart before, so it's got a lot of grime and dirt in it.
Oh, I bet.
And what we're going to do is we're going to run this in what we call a fast burn system. It uses a direct flame.
Oh.
And we're going to basically bake the block at 850 degrees for roughly 1 hour.
Really? Okay. And that'll remove all the grime and the buildup over the years. Huh?
It's going to loosen up everything that's on it. Paint, gaskets, grease, everything is going to get loosened up.
Well, Leo, this is a machine shop, so it's filled with interesting tools. And this one is used to deal with the blocks. Can you tell us a little bit about it before we see a demo?
Yes, Paul. This is our block machining center. Basically, it's a 3-axis bed mill. And what we're working with here today is your good old-fashioned small block Chevy. This is a 400 cubic inch engine. It's from a 78 Chevy pickup truck. It's a regular job going through the shop.
Yeah.
And we're in the process of blueprinting this block.
Okay.
This is one of the operations that this machine is especially strong at.
And when you say blueprinting the block, does that involve 2 or 3 different processes?
It does. In this case, what we've already done is we've machined the deck of the block, so we've given it a specific finish. It's very smooth. We made sure that it's parallel. We made sure that it's indexed in relation to the opposite deck. It's also at the height that we want it to be at.
Okay.
And now we're going on to resizing the cylinders, which is a process of rough boring them to the size prior to honing and putting them in their proper relationship or position on the blueprint, if you will. So in essence, we're actually blueprinting this everyday OE type block.
Wow. Okay. So the first thing we've got to do is use a probe to establish the perimeters of where we're at and where we're going, I guess, right?
Right. And Jesse's going to show us how he puts the probe in, picks up on that cylinder, and then swaps over to the boring head and go rough bore that cylinder for us.
Excellent. Well, let's get started with the process here. First, put in the fixture.
Right, and basically this is what we call a smart machine. And what the probe is going to do is it's going to go down and it's going to find the center line of that bore.
Okay.
And then we have the option of putting it where it belongs, because it probably is within GM's tolerance of 1978.
Yes.
Or we can tell the machine to move it to the exact correct location.
Oh, okay.
So that it would be very precise in relation to the other cylinders being parallel.
So those could be 2 different things.
They could be 2 different things,
Right.
and in some cases they can be off enough so that my basic overbore may not line up on it.
I see. Okay.
And so we found on this block, because he probed it already, that they're reasonably close.
I see. Okay. So the next step here would be to establish those perimeters to bring in the tool that actually bores the cylinder.
Right. So he's found that our location is good. We're going to put our boring bar in, and we're going to go ahead down and rough bore this cylinder.
Okay.
We're going to leave enough material so we then can go into our cylinder hone and put the proper finish inside the cylinder.
I see. Okay. All right. So this is a pretty sophisticated piece of equipment right here.
It is. It's very state-of-the-art. All of the movements table-wise on this have a tolerance of 0.2 of 1,000. So it's very precise.
Move back a little bit here.
Yep. And the setting that he's got it at right now with the boring speed and the feed is actually fairly slow. This machine can be set up to run at a fairly high production rate, but given the fact that we're a custom shop, we can basically set the machine, have it run off on this bore while we're setting our gauges, working across the aisle, so we can always be nearby while it's doing its job.
All right. So it's very smart, but you want to supervise it as appropriate.
Well, as we always say, the machine only does what you ask it to.
Right. How long does this process typically take?
Well, the way he's got it set right now, it's probably about halfway down this cylinder. So for one cylinder, you're going to be looking at probably not more than 2 minutes to rough bore it.
Pretty quick.
Pretty quick by our standards, yes.
Quick and accurate.
Yes.
Leo, this is another pretty sophisticated piece of equipment in the shop, and I guess this one's for honing?
This is for our cylinder finishing. This machine is the Rother H85AX. It's a CNC hone, if you will. It uses diamonds specifically. And what the diamond machine does is it allows us to hit the precision that we want. Typically, when we're done with this cylinder, it's going to be within 1/10 of 1,000th roundness and straightness in all 4 cylinders per bank. So It's very accurate. It's, again, a very smart, sophisticated machine. What we need to do is go ahead and we've got to run the setup. Jesse's already told the machine what he wants it to do.
Okay.
And basically it's going to go ahead through a roughing session, then it'll have a finishing session. And we're going to do a couple of different hones in it. There's going to be the diamonds, and then we're going to do a plateau hone on top of it, which is going to basically give us a cylinder finish ready for piston rings for a very quick break-in time, no oil consumption.
Excellent. Well, let's take a quick look.
Great. Jesse, if you don't mind.
Yep. Heading into the second cylinder now.
Yeah, and you'll see that we have a torque plate on there, which is to basically simulate the assembly of the cylinder head and minimize the amount of bore distortion.
Oh. Mm-hmm.
And again, this machine is a smart machine. It's going to have load sensing. You're going to see where it focuses on certain areas of the bore when it knows that it's a little tight or a little loose.
Oh, really?
So right now it's advancing out. It's going to start honing now.
Mm-hmm. And we're operating in thousandths of an inch at this point, right? In terms of the honing? Right
now he's got it in a rough setting, so we're talking in thousandths. When it gets to the finish, then it's going to be a tenth of a thousandth.
Tenth of a thousandth. Well, Leo, when you're rebuilding an engine, there's a lot of different surfaces that have to be trued up and made to fit within certain tolerances, and this is another part of that process, right?
Right, Paul. What we have here is a big block Ford engine. Mm-hmm. This is based off of the 460 engine family.
Yeah.
This is going to go out the door at 502 cubic inches.
Okay.
It's going in a Cobra replica car. Mm-hmm. And so this part of the process is called align honing, where as opposed to align boring, we're using this large honing mandrel that you see.
Yep. Mm-hmm.
Right, and what we've done is we've lightly trimmed the main bearing caps. You can see one here. And we've basically mocked the assembly of the cap onto the block.
Okay.
We've gone in and we've re-honed that main saddle area. Mm-hmm. And what we've done is we've brought those 5 different main bearing saddles into alignment concentrically. Mm-hmm. And we've also brought them to the desired diameter and size.
Leo, healthy engines require really well-balanced components, and this is a part of that process, getting the balancing down. Can you explain what's going on here and how you go about it?
Exactly, Paul. The balancing is an integral part of the process, and the reason is that we're building an engine that's basically balanced and blueprinted, as you hear the term, mm-hmm. But it's required for the simple fact that we're getting these components from a variety of sources, and they have to be married up to each other.
Yes.
And so the weights are very critical to do that.
Yeah.
And what you'll see here is, in this case, the connecting rod. Mm-hmm. We're buying these as quality components, so they should be within a balancing standard.
Yes.
What we're doing is we're checking that.
Okay.
We're recording all the numbers, which is going to help us keep a database of it, and of course arrive at what we call in our world the bob weight, which we're going to show you in a few moments.
Okay.
And so with the connecting rod, there's 2 different motions in the engine. Mm-hmm. You've got the crankshaft end, which the connecting rod is attached to, and it's going through this motion.
Yes.
And then at the piston end, we showed that at the start of our inspection.
Yes.
It's a reciprocating motion. It runs up and down.
Yes. Mm-hmm.
So we've got to take those 2 separate weights, and when they're properly weighed, those 2 separate weights will equal the total weight of the rod.
Okay.
And so we're going to arrive at that, and then the bob weight basically is going to replicate 1 pair of piston assemblies. So mm-hmm. when I take and put my piston assembly together, mm-hmm. I'm going to have my piston, my pin, my rods,
yeah,
my piston rings, which of course are what seal the piston in the bore,
right,
and my connecting rod bearings. That's where I'm attached to the crankshaft.
Okay.
So I'm then going to have my pair of bob weights, or my pair of pistons that simulate that. Mm-hmm. Once I've got to that part, now I can go ahead and dynamically balance my crankshaft.
Okay, all right, so it's all leading up to that.
Exactly.
Mm-hmm. Well, balancing is a big theme in this shop, and certainly an integral component of that, or important component, is balancing the crankshaft, right?
Right, and so here we have the crankshaft that goes along with our piston assemblies mm-hmm. to our big Ford. Mm-hmm. And what we've done is we've set this up with the bob weights. These are, of course, what simulate our pair of piston assemblies.
Okay, so this is a bob weight here?
Right, so we got 4 of them, times mm-hmm. 2 is 8 cylinders.
Yes.
And so basically this crankshaft now is set up for the dynamic spinning of it to measure the imbalance. And what we've done with the screen is we put in all of the parameters of the crankshaft. So the distance from the center to our correction radius, our length from bearing to bearing, all of these different numbers are put into it so the computer can determine what we need to remove or add and at what location.
Where the weight should be, okay. And then you program it on this keyboard here.
Yeah, we're going to tell everything what it needs to do.
Okay.
And then we're going to go ahead to where we can spin the crankshaft. And what you'll see as I switch over to this screen is that though it might look a little confusing, it really is very simple. We have two planes. This is considered two-plane balancing. And we're going to use the front counterweight, and then we're going to use the rear counterweight. These are the two planes that we're looking at on the screen.
I see.
And so those are where our corrections will be. Now we need to have the machine go ahead and measure that imbalance, and we can consider our corrections.
All right. Shall we press the go button?
Would you be my guest?
I'd be happy to.
And so what this is going to do is it's going to spin it at approximately 500 RPM.
Yes.
Sort of an industry standard.
Okay.
You can see it's making its measurements.
Yes.
And it says, okay, I made the measurements, I'm going to stop and display it.
Oh, okay. All right, so if we look at it closely at this computer screen here.
So what you're going to see is that we've got it set up so it's measuring in grams. And it's telling us that it needs to have 180 grams removed. We're on removal.
Okay.
At the front counterweight.
I see.
And it's given us the location right here. So it wants basically 180 grams removed from here. And I can then go ahead and I can split that up into 2, 3, 4, how many different holes I want to make it look nice and neat.
Yes.
So that's on the front. If you look at our back side, 267 grams, quite a bit more.
Yeah.
The nice part is, though, it's right on the middle of our counterweight. So over on the back, we've got to remove 267 grams.
Okay.
That will probably be done with 2 or 3 holes.
I see.
Whatever looks the nicest.
Okay. All right. All right. And that's going to be a nice balanced crankshaft.
We're going to bring that down to less than 5 grams, which for a part this size, this weight, at the RPM that it's going to operate, would put it within tolerance.
Well, Leo, here's an unusual piece of equipment, but a very important one. What's going on here?
Paul, this is what we call our cylinder head center. This is a Surdy 101. The machine was manufactured in France. And what we're doing here today is specifically we're forming the valve seats. This particular cylinder head is off of a Honda. It's basically an import performance car. And so we've already done some valve guide reconditioning, and Dan has gone through and he's formed or shaped all of the other valve seats. And what we're doing here is a very specific precision competition valve job. And so it's not just the fact that we have valves that seal, but we're looking for a very specific shape on the valve seat that's conducive to flowing more quality air, which means more air at a higher velocity.
More horsepower, right?
More horsepower.
Right.
And believe it or not, that form across the valve seat is very critical. So we have a preferred form that we use that we know makes a difference on the flow bench when we check that.
Okay. All right. Well, shall we see how it's done?
Dan, if you'd demonstrate for us, please. What he's doing now is he's basically aligning it. This uses what's called a live pilot. And it has a very precise fit on the valve guide, and that ensures our concentricity. And he's doing it a couple times just to make sure that it's lined up well.
Sure.
And we can manage the vertical movement in here down to 1/1000th of an inch. So if we want to keep all of our seats the same height, very easy to do so on this. And so the blade that we use, or the carbide cutter, if you will, basically has the shape on it that we want to put into the valve seat.
Okay. Right.
And so he's just going to go ahead and tell it what to do here and bring it on down manually. And the amount of metal removal here is very minimal. And we're very cautious about that. He's doing a little light finish cut at the end there for a good finish. And there you go. This valve seat is complete. The head can now move on to resurfacing and then final assembly.
Okay. Well, we're here in the final assembly room, if you will, and that's where the final assembly process obviously happens. Can you tell us a little bit about this engine and the process that occurs here in the room?
Yes, Paul. This engine is a 428 Cobra Jet. It's out of, I believe, a 70 Mustang. And basically, final assembly now means that we're going to check everything that we've done up to this point. which means that piston ring end gaps, we're going to slide the piston ring into the bore and just put it in, square it up, feel the gauge.
Yeah.
Check and make sure that all of that is what we want it to be.
Mm-hmm.
And then we can go ahead and we can get our piston assemblies assembled so that they can go in. So we'll install the rings on the piston.
Okay.
Our bearing shells, these are insert bearings for the rods.
Mm-hmm.
We're going to go ahead and slide these in.
Okay.
Okay, and then at this point I can go ahead and insert the piston into the bore. I don't have my crankshaft here, but you kind of get the idea where it would go.
That would be typically the first thing. You put the crankshaft in and torque that down, right?
Exactly, and then I can go ahead and I can compress my rings, and I can slide the piston into the bore. Quite often we'll do this with two people.
You will.
And the reason is that, again, we got two hands, two sets of eyes. It all just is a better way to keep a tab on things.
Oh, okay.
One guy is installing, one guy is receiving. So I'll go ahead and slide the piston in.
Right.
He's going to slide the cap on. He's got the lube and the torque wrench. And then we can go ahead and tighten up the rods.
All right.
And we would do the same thing with the crankshaft. And then in terms of our bearing sizes, both rod and main, we check everything with our dial bore gauge. So once we've tightened up our rod caps, we can take our bore gauge and we'll go ahead and slide that through.
Okay.
And we're going to see that all of our bearing clearances are right where they should be.
Okay. All right. So a lot of checking, very slow, methodical, gentle process.
Right. And we're going to go ahead and we're going to document it. So we're going to basically generate a build sheet. So we've got future database if we need to refer back to it.
Right, right.
What sizes did we use if we need to answer any questions?
Got that database, got that foundation of information.
Exactly.
Now if we go over to this engine over here, we're a little further along. What are we looking at here?
Right. This is the next step. This particular engine is a big block Chevy. It's 598 cubic inches. This is going in one of our vintage boat projects.
Oh yeah.
And we've got the engine basically built.
So we've got the crank in, we've got the pistons in, we've got the rings in.
We've got the cylinder heads on, everything is torqued and tightened.
Yep.
We've got to go ahead and install our valve train, and then the remainder of the induction system, which would be our intake manifold, and then get into our carburetor, what we call our accessories
or
peripherals.
The alternator,
distributor.
the starter.
Well, no alternator, but
no
distributor.
Alternator. Okay.
So at that point, we'll get the engine fully dressed and it can go into the testing department.
Leo, looks like you got a lot of engines in queue out here. What's going on?
Yeah, in our engine testing department, Paul, the first one that you're looking at here would be 71 Mustang. This is a 351 Cleveland. It's stock original appearing. However, we've oversized the engine. It's a 408 cubic inch engine with some other modifications. It makes roughly 440 horsepower and just about 500 foot-pounds of torque on paper. But we're going to see what it actually does in the testing, which will be coming up shortly.
Check it on the dyno. How about we got a couple other ones here?
Yeah, behind that, this is a 69 GTO, 400 cubic inch. This is basically a Ram Air 4 engine, so it's essentially built to a factory spec. So no huge power numbers, but we've got to make sure that it does everything it's supposed to do.
Okay.
And then after that, we've got a pair of big block Chevys. This is for a performance boat.
Yes.
So these started out as 502s. They're actually sized up to 540 cubes each now.
Wow.
With a pair of the older B&M superchargers, kind of mild by today's standards, but these engines should make somewhere in the neighborhood of 800 horse each.
Okay.
And this will be just fine for what he wants to do.
And the dyno's going to help you verify that.
This is going to help us hit the number and make sure that they've got good manners and work well.
Excellent. Well, Leo, we're knee deep in the dyno room now. We've got an engine up front and we've got the dynometer here in the back. Can you orient us to what we're looking at?
Yeah, what we have, Paul, this particular engine is 500 cubic inches, big block Chevy. It's naturally aspirated with a carburetor, high compression. It's going to develop somewhere just shy of 800 horsepower. The dynamometer that we're using here is a Superflow PowerMark. That's their model. And its rated capability is 3,000 horsepower or 15,000 RPM.
Okay.
So if we have one of the high RPM import engines, or if we have a high horsepower domestic drag race engine, we've got the capability to handle that. This is a water brake dyno, and what it basically uses is what we call our absorber. And there are different designs. This is the one that's most commonly employed, and it's what we use. So we basically use water with a control system mechanism computer that controls that whole process.
Interesting. Yeah.
And what happens is there's a lot of data acquisition, and up behind us here we've basically got the collection point where there's a computer inside.
Yeah.
And all of our pressures, temperatures, RPMs, weather, everything is taken into consideration. Then all this information is fed out to our console where we can then view it and make our determinations from there.
Right. So you don't use this simply to measure horsepower or torque, but you also use it as part of the tweaking process, right?
It's a tuning tool.
Yes.
So when we start the engine initially, we're going to be very cautious. And quite often, again, we're going to employ 2 people here.
Yeah.
Because we want to have 2 minds, 2 ears, 2 everything working on it. And then, again, we look at the numbers, we creep up on it as long as we see temperatures and pressures, everything is looking normal, then we'll sneak up on it.
Yeah.
So what we don't want to do is hurt the piece that we're working with.
Absolutely. So easy as it goes.
Exactly.
Yep. Leo, we've got an engine running in the Dyno Room. Can you explain a little bit about what's cooking, and then we'll come off stage here, if you will, and focus in on the results?
Yes, Paul. What we're doing is we're getting the engine all warmed up. We want to make sure that all of our temperatures are ideal. Our oil, our water temperature, they've got to be optimized. Make sure that the engine's ready for a run. Everything sounds right, looks right. And then Andy's going to go ahead and do a poll for us.
All right. So why don't we step off the screen, let the camera focus in on the screen, and you can talk us more to the results.
Sure.
So what's Andy keeping an eye on here?
Andy's basically watching it. We want to see our coolant and our oil primarily come up. We'd like to see him within 1 or 2 degrees, as close as he can. And so he's going to basically, between the RPM and the load, he can impose a load on the engine right now, which can influence where the oil temperature goes. And of course, he's keeping an eye on the air-fuel ratio as always.
I see. And you've got a couple, I've got a red and a blue semicircle down the bottom. I got engine power and engine torque.
Right, so he's going to be watching that stuff. He's got a little bit to go.
Yeah, this is a big engine for 11 horsepower showing at 35 pounds of torque.
Once you start to put the load on it, then it'll measure the power. So,
is that right?
Yeah, right now that's all it's getting for a load on it.
All right, so now we're not seeing a load on it right now.
Right.
Yeah. Putting a load on it. Got a lot of torque. Well, Leo, it's hard to believe, but time to wrap up the show today, and I think we've covered a lot of interesting aspects of what goes on in a engine rebuilding shop. Do you have anything to add before we close out the program?
Well, of course, thank you for the experience, Paul. We've enjoyed it so much. And, you know, at the end of the day, if you do have the experience of rebuilding an engine, make sure that you do, find a competent engine builder and make sure that you enjoy the process and trust their advice and experience to steer you in the right direction.
Right, you got to kind of keep, if you get involved in the process, you got to keep open, right? Because in these series of evaluations, tests, and inspections, things might crop up that you couldn't anticipate at the beginning, right? So that's why you're saying keep an open mind to things.
Exactly. In the beginning of the process really is the most critical, that everyone, figures out what the best thing is to do.
That's a good point. Great, great. Thank you.
You're welcome. Thank you.
And thank you, Smart Boating viewers, for joining us. If you have comments or questions, come visit us at www.smartboatingus.com. Thank you.